Hello there and welcome to a brand new lesson. This is Hard Beyond Numbers where we learn maths the easy way. In this lesson, we are looking at question 12 of WASSCE 2026 core mathematics paper. By the end of this lesson, you should be able to understand the properties of an arithmetic progression. You'll be able to find a common difference in unknown terms in an arithmetic progression. You'll be able to calculate the mean of a data set, and then you should be able to calculate the standard deviation of a data set as well. On the left-hand side here are answers to the trial exercises I gave on question 11, which is on the playlist. You can confirm, you can check that's your answers, and then you do your correction. Without much I say, let's quickly look into this. So question 12 says, the ages in years of 6 students are arranged in order of magnitude. 2x plus 1, 4x minus 1, 5x, m, n, and then r. If their ages form an arithmetic progression, we have to calculate the ages of the students. And secondly, we have to find the standard deviation. This is the whole question. That is for question number 12. Compared to all that we have solved, even especially question number 11, I think this is the easiest, and I'm sure most students chose it because they are just these questions for the complete question number. Now, the key things we are supposed to note here, that is the key concept to be able to solve this question, is you need to know what an arithmetic progression is. So there's arithmetic progression and there's geometric progression. The arithmetic progression simply means there is a constant common difference between the terms. So if you take your first term, and then your second term, and then your third term, we find the difference between the second and then the first term. It should be the same as the difference between the third and then the second in that order. So we say D equals T2 minus T1, and it's also equal to T3 minus T2. And we know what the mean is. The mean is simply the sum of all the terms divided by the number of terms. But then the standard deviation is what we have here. The mean of the deviations. Right? So let's first of all start with the first one. For the first one, we have the terms being what? A 2x plus 1. And then the next one being a 4x minus 1. And then the next one being a 5x. And then an m, n, and then r. Now, since we are taking their word, which says it is an arithmetic progression, then we say for arithmetic progression, it implies that if this becomes a first term, or let's use the standard notation. So we would say this one is u1, u2, u3, right? So for arithmetic progression, it simply means the difference between u2 minus u1 should be the same as the difference between u3 minus u2. So our u2 is simply 4x minus 1, then minus u1. That is what we have here. So minus 2x plus 1. And we are saying it should be equal to u3, which is 5x. So 5x minus u2, which is the 4x minus 1. We are saying this because of this formula. That is D, the constant difference. They should be the same. So with this equation we now solve for x. They are just one in front of the bracket, so we can open them simply. We have 4x minus 1. Then this negative affects the 2x. And it also affects the 1 as well. So that we have negative 2x minus 1, which is equal to your 5x. Then this giving us a negative 4x. And then negative times 1 gives us a positive 1. We can now simplify and group like terms. So we have 4x minus, let's group like terms first. So we have 4x minus 2x minus 1 equals This has already been grouped. So 5x minus 4x gives us an x plus 1. This, on the other hand, we have 4x minus 2x, which is a 2x. So 2x minus negative 1 minus 1 gives us a negative 2, and that is equal to x plus 1. We can move this x to the other side so that we have a 2x minus x, which is equal to a 1. Then this 2 moves to the other side. It is a negative 2 here, so it moves to the other side as positive 2. And 2x minus x simply gives us an x. So we have x is equal to 3. Now, if x is equal to 3, we now need to find all these terms, you see. And we now use the general formula of an arithmetic progression. So we say un is equal to a is the first term, plus n minus 1 times d, where n is the term we want. Hence, let's look for our a. A is simply the first term. And we know the first term, u1 or a, was given as what? 2x plus 1. So substituting, we have 2 into bracket our x, which is 3, then plus 1. 2 times x gives us a 6, so we have 6 plus 1, which gives us a 7. So then, if you have to substitute that into un, our un is equal to what? A, which is 7, plus n minus 1 d, and we said our d is the common difference. Have we found that? Have we found the common difference? We don't have the common difference yet. So let's look for the common difference. Now, how do we get the common difference? We have found u1 to be 7. So we need our u2. u2 is simply what? 4x minus 1, and we know what our x is. So our u2 is 4 into bracket 3 minus 1, which gives us a 12 minus 1. And 12 minus 1 is an 11. So with these two terms, we can now look for our common difference. So the common difference in this case is going to be what? We know the general formula for common difference is u n plus 1 minus u n. So that is 11 minus, that is the second term minus the first term, 7. Hence, our d is going to be what? A 4. We now come and write the general formula for the arithmetic progression. So the arithmetic progression is given by what? AP is, or let's say un. That is the nth term is what? A plus n minus 1 d. And we have our a and d. So our a, which is 7, the first term, plus n minus 1 d, which is 4. That can be simplified further as 7 plus 4 times n, which gives us a 4n. Then 4 times 1 gives us a negative 4. Simplifying further, we have 7 minus 4, which gives us a positive 3. So that is to say, if you want any term, we can substitute into this formula 4n plus 1 to get the term. Now, we already have our u1, that is the first term, which is 7. And that was actually what was given us 2x plus 1. And we also have our second term, which is 11. And that was what was given as 4x minus 1. Now for our third term, u3, it was given as 5x. So you can simply substitute your 5, which give you a 5 into bracket your x. and we had our x to be 3. So we put our 3 here, and that will give us our 15. You see? So that is our third term. But the fourth term was giving us m. So our fourth term, which is u4, was giving us m. But how do we get it? That is why we need this formula. So that was why we went through all we did to get our d and then our a. Hence, for u4, that is the fourth term, using the formula we have here. 4 into bracket n. N is the term. So 4, then plus 3. 4 times 4 gives us a 16. So we have 16 plus 3. And 16 plus 3 gives us a 19. So that is the fourth term. Then for the fifth term, which was written as n, we do the same substitution. So 4 into bracket, this time around, it is 5. Then plus 3. 4 times 5 gives us a 20. So we have 20 plus 3, which is also a 23. Then for the last term, which is u6, you do the same substitution. In the question, it was given as r. So substituting for what? 4 into bracket 4. 4 into bracket 6. Since that n is 6, then plus 3. We have 4 times 6, which gives us a 24. So 24 plus 3, that gives us a 27. So we now have all the terms, you see. So we can then say, therefore, the ages are, that is to say, the ages of the students are, we have 7, 11, 15, 19, 23, and 27. And that is all. Now, rather than solving all of this, when you had your first and then second term, you realize that you know the common difference, which was 11 minus 7. 11 minus 7, we said, give us a 4. So you keep adding 4 to it. So from 11 plus 4, we have 15. 15 plus 4, you have 19. 19 plus 4, you have 23. 23 plus 4, you have 27. And that would have also worked. Now, the second question was where to find the standard deviation. Now, to get the standard deviation, then we would need the mean. If we find the mean, then we find the deviations of all these ages against the mean, and then we can now solve for what the standard deviation. So, what is the mean? The mean is simply, the mean is simply the sum of all of these divided by the number of entities. So the sum here, we are talking of, well, you can also use a table as well to do that. And I think that will be better. So let's draw a table. So that's what we have as our table, and we are going to put our x values here, and we'll gradually find the sum of that here. And then we'll look for the deviations, and then the square of the deviations also are going to be here. Since their frequencies are just 1, there's no need bringing the f. So we have 7, then an 11, a 15, a 19, a 23, and then a 27. Now the sum of all of this, that is sum of x, is going to be equal to 7 plus 11. That is, if we add all of this, we have a 102. So we have the sum. Now, since we have the sum, we can then find the mean. So the mean would simply be what? The 102 all over 1, 2, 3, 4, 5, 6. There are 6 entities. And that is going to give us a 17. Then we find the deviations of all of this from the mean. So for the deviations, each x value minus the mean. So we start from 17. 17 minus 7 minus 17 gives us a negative 10. 11 minus 17 also gives us a negative 6. 15 minus 17, we have a negative 2. 19 minus 17, we have a 2. 23 minus 17, we have a 6. 27 minus 17 gives us a 10. Then we square all these deviations. So 10 squared gives us 100. 6 squared gives us a 36. Negative 2 squared, sorry, so negative, right? Since we are squaring the negative numbers, we'll be getting a positive result. So negative 2 squared gives us a 4. 2 squared gives us a 4. 6 squared gives us a 36. And then the 100 square also gives us, the 10 squared also gives us 100. If you have to find the sum of all of these deviations, that is sigma x minus the mean all squared, then we have to add all of this. And adding 100 to 36, 4, 4, 36, and 100 gives us a 280. So with this information, we can now solve for the mean deviation. So we know the mean deviation is given as what? This the sum of the deviations squared all over the number of entities. Not forgetting the square root. All right. So substituting, we have 280 all over the number of entities, which is 6. Then we find its square root. At this stage, you can just punch this on your calculator, which will then give you a 6.83. So we then conclude by saying, therefore, the standard deviation of the ages is approximately 6.83 years. And that ends this question. So, you see, the question was very, very simple, but we just had to do a lot of things. All you needed to know was your formula, and with your formula, you can easily work this out. I'll leave you some trial questions that are related to this so that you can also use that to test your understanding. So we have 5 questions here that are related to what we just solved, and you can try them just to test your understanding. The answers will be reviewed at the start of the next lesson. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know at the comment section. And when notified, I'll address that for you. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.